Let's do it. A lot of parts here to density. First is the formula. All right, density of an object. And I said sphere would be the only one, surface area of a sphere. I guess there is a second one, and that's density. Mass divided by volume. Okay, density, mass divided by volume. There will be times, I don't think today, but starting tomorrow, where you're going to have to convert some units to different units. That's on your formula sheet. All right, everyone see what's on their notes right now? This little rectangle of conversions, that's on the top of your formula sheet. So you have those. If a conversion is not given, I will give it to you. So it's not like the only thing really you are on the hook for is 12 inches equals a foot, and I think you can handle that. All right, any other conversion will either A, be on your formula sheet, or will be given to you in the problem. All right, so density, mass divided by volume. So what are, just let me go over quickly, different types of masses we'll deal with: kilograms, grams, pounds. Okay, those are all different types of mass. Weight, all right, weight, mass. Those are all different types of masses we'll be dealing with. So we'll take the mass and divide it by the volume. All right, we ready? We're going to jump right into this. There's a couple things I'm going to warn you about as we move along, but we'll start with a very basic problem that was on the Regents exam a couple years ago. So we have a cube that's got an edge length of 6 and a mass of 137.8 grams. What's the density to the nearest thousandth? And then use the table to tell us what type of wood we used. Okay, so it's asking us find the density first. So we know density, mass over volume. Mass over volume. We are already given the mass, 137.8. And here's where you're going to have to do some work. Find the volume. Okay, that's why we put it in this unit. All right, what is the volume of this cube? So off to the side, we'll calculate volume. It's a cube, a prism, right? A prism. If you got to look back, BH. Volume, BH. So how am I going to find the volume of this prism or this cube? Every edge is 6. So think about the base. How would I find the area of the base? And then times the height. All right, so what are you multiplying together here to find the volume? Start us off right. 3, Spence, what do I multiply together?
6 and 6.
6 and 6 gives me the base, right? And how about the height? Also 6. So I should be multiplying 6 times 6 times 6 there. So we get a volume of 216. Go ahead, plug it in. Divided by 216. And go ahead and round appropriately. Nearest thousandth, you should be giving me 3 numbers after the decimal. 12 when you're ready, point. Got it. 0.638 is the density. And now it says, all right, state which type of wood this cube is made out of using the table. So I wouldn't even ask anybody. We see 0.68 ash. We all good? Just finding it. Because now I'm going to get a little more complicated. Just finding density. All right. Here we go. Shipping container. It's a right rectangular prism. So it's a prism, rectangular prism, 12 feet. Yep. Width. Yep. Height. We got it. Completely filled with contents that weigh on average 0.25 pounds per cubic foot. What's the weight of this container? All right. First of all, nobody sees the word density in this problem. But there's a number up there that represents density. Remember, go back. And this is, I'm going to start getting real fired up here. Density, mass divided by volume. mass over volume, right? So if I go back here, 0.25 pounds per cubic foot. Does everyone see? Mass, volume. We see that. So that 0.25, that's my density. Even though I don't say the word density, we need to recognize, darn it, that number's the density. Why? Because it's pounds over volume, cubic feet, right? Anything that's cubed, we said, was volume. So 0.25 is the density. I'm looking for what is the weight in pounds of this container. So go to our formula right now. D equals M over V. We know the density already. We know the density. It's 0.25. Stop. Everybody stop. We need to get in this habit every problem going forward now. Do the units on the density match the units on our object? Do the units in our density match the units in our object, aka the container? Here's what I mean. On average, it's 0.25 pounds per cubic foot. What's the container in? Also feet. We're good. Because if they're not, I need to convert these units into whatever the density is. So I am going to stop you every single time and say, do the densities units match our objects units? Because if they don't, we do need to convert. All right, so 0.25 equals M, the mass of the container, over, all right, this is on you now, what's the volume? Okay, what's the volume of our container? So we got to go off to the side. Our container is a prism. So I do the formula BH. And what am I multiplying together to get the volume of this prism? It's 8. Sophia?
12
times yep.
8.5 times 4.
Times 8.5 times 4. Good. And what do you got for the volume of the container here? Sophia, again, go ahead.
408.
408. I plug that in. And I think we're comfortable solving this. Cross multiply if you want. Put the 0.25 over 1. Cross multiply. And then what is the mass of the container then? 4. What's my mass of the container?
102 pounds.
What do you have?
102 pounds.
102 lbs. Yep, that's pounds, kids, on the streets. You have to make sure your density units matches your object. I don't think that's going to be an issue today, but I know it will be tomorrow. We're going to have to change the units before I start finding the volume. Anything? Okay, I'm coming down hard today because I know how tough this stuff is. All right, let's do an oak tree. Oak tree. Oh, all right, I just come out and say density, right? So I don't even have to worry about that. 752 is your density. Even if I took that word out, it shouldn't matter to us. Kilograms, mass, per cubic meter, volume. So even if I took the word density out, we should know, hey, 752 is the density. The trunk has a circumference of 0.45 meters and a height of 12. What is the approximate number of kilograms of the trunk? All right, so we're finding mass again, right? D equals M over V. Density, 752. We're solving for the weight, the mass of it in kilograms. Whoa, everybody stop. Is our density in the same units as our tree? Cubic meters? Meters. Okay, we're good. We have to check that. Okay, because if not, we need to convert the units. We don't have to in this one. All right, you guys ready to find the volume of this tree? So I can plug it in. First of all, it's a tree. What shape are we dealing with? Because we've been dealing with prisms the last two problems, and this is not a prism. What shape are we dealing with here? 7? Cylinder. All right, so everyone, if you got to go back and look. What's the volume formula for a cylinder? 12?
Pi r squared h.
Good job. So the volume, pi, I do not have r. I'm going to need your help with that, but I do have the height of it, right, is 8. Okay, can I get your help with finding the r value now? What other value is given up there? That 4.5 is the what? 4? What's the 4.5?
Circumference.
All right, and unit, I think yesterday we used it too. What's my circumference formula? I think that's even on the formula sheet too, to be honest. You guys are giving it all. What's the circumference formula I can use here? 9? I think it's on there, right? Circumference.
Is it 2 pi r? Oh, wait.
Is it? I don't think is 2 pi r on there. Oh, they took circumference off. Oh, no. Yeah, it's on there. Circle. It says circle. C equals pi d or 2 pi r. Yeah. We always use pi d though. All right, so I plug in 4.5. Everyone's with me? 4.5 for the circumference equals pi d. How are you going to get d by itself? 8. How am I going to get d by itself?
Divide both sides by pi.
Great job. Divide by pi, but I need the radius though, right? I need the radius. So take that number in your calculator and cut it in half after you're done. Take that number, cut it in half, and there's your radius. Everyone's good and has the radius now? Because now I'm going to plug it up here. All right, so we should have, let's see, if I have done this correctly, 0.7161972,439. How's that look for the radius? Tell me if it's wrong, too. So that's going to go up here. Find the volume now. Pi times that times 8, and I'm going to write down it's 12 point. And notice I'm not rounding anything. I'm writing out all the numbers on the calculator. And then we plug it in and cross multiply. And what are we rounding to? We'll go whole number just as approximate number. What's the whole number here? What's the weight of this tree? Nearest whole number. When you're ready. 9 when you're ready. Got it. Kilograms. Okay, how we do? This is basically today. You guys are going to be finding a lot of mass today, a lot of mass. Tomorrow we get real hardcore and keep going. Any issues yet? I'm only going to do a couple more and then the rest is the assignment, so. All right. Hemispherical tank, all right, filled with water, diameter of 10. Water weighs 62.4 pounds. Oh, what did I just give you there? 62.4 pounds per cubic foot. What did I just give you? Density. Thanks, Spence. And timeout. Does that density units match the tank's units? Cubic feet, diameter of 10 feet. They match, all right? I know we're just going to assume probably they're going to match, but sooner or later they're not going to match, and we got to make a change. What's the weight of the water? All right, so we're doing mass again. D equals M over V. Density is 62.4. What's the mass? All right, help me find the volume from yesterday. Hemisphere. What you guys got for me? Volume of a hemisphere. Volume. 2. Yep. 7. Volume of a hemisphere.
Was it 1 1/2, 1/4?
Yep. So I'm going to take the 4/3 pi r cubed for the full sphere, cut it in half. I also just said take half of it too. You can just multiply it by a half. Good job. So 4/3 pi, radius is 5 because the diameter was 10 cubed, and we're going to cut that in half. Again, not rounding anything. I'm getting about 261 and change. And then I'm going to plug that in for the volume here. And to the nearest pound when somebody's ready. To the nearest pound. Nine when you're ready, nearest pound. Woo! It's one heavy tank. It's a heavy tank. All right, I'm going to skip over here because the homework is to finish some of these problems, so I'm not going to keep doing the same type of problem. You guys can practice them. Yep, that's about the same. I'm going to do kind of a different one. Height of inches. How much does the brick weigh? Yeah, standard size golf ball. Golf ball weighs per cubic inch. What's the weight of one golf ball? Okay, no issues yet. Well, we go to the last one there, 9. I'll do you a solid and we can do the big dog one. And then I'll let you guys go and finish the rest of them for the assignment. All right. All right, here you go. Walter wants to make 100 candles in the shape of a cone. The mold below will be used to make candles. Each mold will have a height, diameter to the nearest cubic inch. What's the volume of 100 candles? Okay, what's the volume of 100 candles here for part A? What shape is the candle in first so I know what formula to use? 12? Cone, yep. All right, so can somebody hook me up either on the formula sheet because you know it already? What's the volume of a cone? 13. Charlie.
V equals 1/3 pi r squared.
There you go. Nice having that little sheet there. All right, can you help me fill it in then? Volume equals 1/3 pi. What do you got for me next? 10. Radius? 1.5. Good job. And how about the height again? 8. Yep. Now remember, this is for one candle we're going to calculate, right? This is only for one candle. Okay, there's one candle. Let's go 100, so times 100 of them. The volume will be nearest cubic inch. 1,885 cubic inches. We're all good on part A. Here we go, part B, and this is tomorrow, basically. I'm giving you a sniff, a taste of tomorrow, because this is where we need to be with these density problems. All right, so he's got to have wax for the candles, and the wax costs 10 cents per ounce. The weight of the wax is 0.52 ounce per cubic inch. What did I just give you right there? 0.52. What is that? That's density, right? And it matches inches, right? That's what our candle's in. All right, perfect. How much will it cost Walter to buy 100 candles? So let's stop right there. All right, let's answer that first because this is a two-part question. All right, how much is it going to cost him to buy 100 to wax for 100 candles? And we know a wax costs 10 cents per ounce. So the first thing we're going to need to find is what's the weight in ounces of this 100 candles. So density equals mass over volume. Again, we are finding the weight. Everyone see what our plan is? We'll find the weight of the 100 candles, and it's 10 cents an ounce. So we're going to find how many ounces it takes to do 100 candles and then use the 10 cents. Density, you told me, was 0.52. What's the mass for the 100 candles? And we already know the volume, right? 1,885. So how much does 100 candles weigh in ounces? I'm getting 980.2 ounces. Everyone, yes, for 100 candles, we're good? All right, it costs 10 cents per ounce. So how much is it going to cost for the wax? Costs 10 cents per ounce. What are you going to do here to find how much it cost with that 10 cents? 5?
Multiply it by 980.
Yep, 980.2 times 10 cents an ounce, or make a proportion out of it, right? 1 ounce equals 0.10 over 980.2 equals X. Make a proportion out of it. So it's going to cost us $98.02 for the wax. We're all right. And then here's the last part now. We know how much it costs for the wax. If Walter spends $37.83 for molds and he's going to charge $1.95 for a candle. All right, so every candle he sells, he gets $1.95 back, but he also has to pay $37.83 for these molds. Doesn't matter. How much profit is he going to sell from 100 candles? And I gave you guys a little hint here. Profit is found by taking the money earned. So hey, let's stop there. How can I find how much he's going to take in? How many candles does he have? How many candles? 100. And how much is he selling them for? $1.95. So this is right here. This is how much he's going to earn. All 100 candles times $1.95 a piece. But he's got some costs associated with it, right? He spent some money on it. So I need to subtract out. Tell me what money he spent on it already. The wax, which we know how it costs what?
98.
So minus 98.02 for the wax. And he also spent some other money. What else did he spend it on? The molds, right? Yeah. We also have to subtract out that $37.83 because he had to spend money on the molds. So that'll show right here what his profit is. He'll make this amount right here, but then he's got to subtract out what he already spent. So what are we looking at there? 195. Not really a great business plan. All that work for $59.15. Not the best business plan, huh? That's where we're going tomorrow. And we're going to be changing units tomorrow too. But this is where we are, guys. This is where I need you to be by the end of tomorrow. But you guys now just worry about finding mass now. Okay? Make sure you know what type of figure it is so you can find the correct volume. All right, go ahead and get started. You guys know the answer keys online.